A very good afternoon, respected dignitaries, faculties, and participants. I am Surya, lecturer, PG Department of Computer Science, Kasturba Gandhi Degree and PG College for Women. On behalf of me, Kasturba Gandhi Degree and PG College for Women, the entire academic population, it is a distinct pleasure to heartily welcome you all. I suggest you to savor the moment. Now, I cordially invite Vice Principal Madam Dr. Rashri R. to address the session.
Ms. Raji, ma'am, you can start.
Dr. Doreen, can you hear me?
Yeah, we can hear you. You are on live, ma'am. You can start. You're on the screen. You could start addressing, ma'am. We could hear you. Raji, ma'am, you can start speaking. Raji, ma'am.
Hello.
Sunita, ma'am, you can.
Yeah, ma'am. She is able to hear you, ma'am. Raji, ma'am, is unable to speak. Her mic is off.
Okay. I switched it on. Okay. But she's on other call, I suppose.
I just called her.
Okay. Raji, ma'am, you can speak, ma'am.
I cannot. Sunita, I cannot hear you all.
Now we can hear you.
We are able to hear, ma'am. You are on live. You can start speaking. You can start speaking now.
Can you all hear me?
Yeah, ma'am.
Yes.
Yes, can you hear me?
Hear you.
Yeah.
Yes,
Yeah.
we can hear you. We can hear you.
Now we can start with it, ma'am. Rashri, ma'am.
Good afternoon, one and all. On behalf of Kasturba Gandhi Degree and PG College for Women, I extend a very warm welcome to Dr. Doreen Robin, Director CIRF, Computational Intelligence Research Foundation. Madam is going to have a talk, or rather give a talk on machine learning and deep learning. And it's a national webinar. I welcome you and thank you, madam, for coming on to this show.
Thank you.
And I also welcome all the participants who are part of this show, and I'm sure there's a lot to take away. I congratulate the department, PG Department of Computer Science, the head, Dr. Sunita, and all the members of the department for organizing this national webinar. And I hope you all have a great day. Thank you.
Thank you. Thank you, ma'am.
Thank you, madam. Now I request Head PG Department of Computer Science, Dr. K. Sunita, madam, to introduce the speaker.
Good afternoon to all the participants. I'm happy to see the enthusiastic and overwhelming participants here for today's seminar. To handle the pandemic situation, technology is found the best in bringing the people together. So here we are. It's my privilege to introduce today's speaker, Dr. Doreen Robin, Director, Computational Intelligence Research Foundation. She has completed her engineering and post-graduation from Anna University. She received her Ph.D. in Computer Science Engineering from Anna University. She had been guiding many research scholars. Her areas of interest are parallel computing, distributed computing, grid computing, cloud computing, and big data analytics. I hope today's session will make us take away these learning concepts and implement them in the future. I am proud of my team for their support and made this webinar possible in short span. Thanking you all. Now I request Dr. Robin to continue with her lecture.
Thank you, ma'am. Good afternoon to all the participants. Thank you for joining on this webinar. All right, so we are going to start a session right now. And on behalf of Computational Intelligence Foundation, I welcome you all for this webinar. We are going to see for the next 1 hour about machine learning and deep learning. Okay, and whenever you have got a question, you can put it onto the live chat. So as and when I present my screen, I'll be asking you the questions, and you can come. Your questions will be broadcasted on the screen, and your questions will be answered. Now let's begin. So for today's session, we are going to see about machine learning and deep learning. I would like to convey my thanks to the college, those who have invited me for this webinar on machine learning and deep learning. So the session would go like this. We'll be seeing about the concepts of machine learning, deep learning, and a live demo of how we are going to take a data sets and how are we going to put into a system and how we are going to do the training, the testing, and eventually, and how the prediction we are going to do it, right? I'm Dr. Doreen Robin. You can see on my screen. Okay, I'm the founder director of Computational Intelligence Research Foundation. Okay, it's in Chennai, and the website is www.cirf.co.in, and you can see my email doreencirf@gmail.com, and my mobile number is 900-30-21355. So basically, I was working for engineering colleges for a decade. Okay, I had worked in Anna University, SSN, SPC, Loyola ECAM College of Engineering and Technology. After which we started this company, CIRF. It's a Section 8 company, where predominantly we work on research projects, finding solutions to problem using the latest trending technology. And in addition, we give training for faculties on having an online classroom during this lockdown. By the grace of God, I've trained more than 600 plus teachers who are purely non-technical, and now their classes are all online. And we work on big data analytics using Hadoop. We work with machine learning, deep learning, Apache Spark, cyber forensics, software testing, and so on. All right. So what is machine learning? Okay, most of them have a doubt. What is machine learning and what is deep learning, right? The question is always there among people. So machine learning and deep learning, they discover patterns in the data. So we can work with n number of data, feed it onto the system, and figure it out the patterns that is available. But they involve dramatically different techniques. Both machine learning and deep learning, they are going to discover patterns in the data, all right? But they are very different the way that they do. And we will be seeing in depth about machine learning and deep learning. So the concepts is the same, the ground is the same, but the way they're launched is different. One is machine learning and the other one is deep learning. Okay, they are both forms of artificial intelligence. Okay, first, basically, we are artificial intelligence. Okay, where we work or we train the machine to respond to a request, but which needed some guidance. And then we moved on to machine learning, and now the trending technology is deep learning. Right? Deep learning is a specific kind of machine learning that we should understand. Okay, both are forms of artificial intelligence. Both machine learning and deep learning are forms of artificial intelligence. Okay, deep learning is a specific kind of machine learning. Both they started working with, in both we'll be seeing in the session today. In both we'll be working with training data. We work with testing data. So we'll take a set of data, we split them into training data, and we split them into testing data, and we feed it into a model. Okay, for modeling, we feed into a modeling, and that goes through optimization to find the weights that makes the model best fit the data. All right. So now, specifically, I'm going to ask you a question. Okay, we have got a number of participants to this webinar. I'm going to ask you a question. You can put on the chat session. Can you give any real-time examples of what is machine learning? You can type it out and you can put it on. What do you think on your real day-to-day timing? What do you think? What yes, I could see. Yes, it will be, the entire session will be on YouTube channel, sir. Okay. Yeah, predicting the house prices. Okay. So Harsha ma'am is predicting house prices. And Hamid sir, he has said facial recognition. Yes, right. You can see the questions that you're answering. The best example is the washing machine. Okay, what does washing machine do? Okay, we feed our clothes into the system, and the system is programmed in such a way, if it is a cotton, how does it wash it? If it is a silk, how does it wash it? Yes, I could get very good questions. Google search engine, yes. I can see Google search engine. Alexa, best. Okay, a lot of recommender system, okay? And we'll be seeing about the examples of recommender systems, okay? To detect spam emails, okay? To detect spam emails, okay? Biometric recognition, very good participants. Medical diagnosis, okay? Speech recognition, all your answers are put on. Weather prediction, yes, okay? And medical diagnosis, yes, exactly, okay? So many. Thank you all for your answers. Okay, so we have got more than 180 participants on live, and so these are the different machine learning. So a machine is trained in such a way that, so whatever the request, I'm according to my input, yeah, image diagnosis. Thank you, sir. So whatever I'm going to feed into my system, accordingly it will be given. All right. So same way here in machine learning, another example that we could see is that, okay, another example that we could see is we have a set of students. Okay, we have set of students in a college. So the first day, first semester, we will not know much about the students, right? We will not know much about the students, how they are, how they learn, how they do. Okay, that and all, we are not aware of it. Okay, but eventually after we take a class, the students, how they respond, we know few about them, how do they do it. Okay, accordingly we train the students with series of tests. So by the, before the student goes to the end of the exam, we will know how students will respond to it. We will know how the students will respond to the exams, whether they pass or they fail or what is to be done. Okay, so here also in the same way, we are going to take a data. Okay, we'll be feeding into a data set. We'll be doing a training phase and your testing phase. So before we start, we should clearly understand what is artificial intelligence, what is machine learning, and what is deep learning. All right. So first to start with machine learning, machine being able to carry out the task in a smarter way. It covers anything which enables the computer to behave like humans. But humans cannot be replaced, but it does part of the work. So that was the basic, okay? That was the basic of evolution of the machine learning and deep learning. The base foundation is artificial intelligence. Then comes machine learning, okay? It's a subset of artificial intelligence, and the idea that machine should be given to data and should be left to learn and explore for themselves. So in artificial intelligence, we need more help from the human to train and even to predict the data in artificial intelligence. Okay, that amount of human involvement was reduced in machine learning. That involvement was reduced in machine learning, where we given the data, we give the training data and the testing data. Once I give my testing data, it will be able to figure it out. All right, and then it works with patterns. Okay, it works with patterns. What kind of patterns am I giving into the system? in our research lab, we have worked with more than 10 lakhs and 20 lakhs of data. And then we have got the results very in seconds, less than seconds, right? So where a data set is given in machine learning, you should understand the data set is given to the system, and the system is going to work out with the patterns. We'll be seeing in depth about it. And what is deep learning? It is a subset of AI. So sorry, subset of machine learning. Machine learning is a subset of AI. Deep learning is a subset of machine learning. Okay, and here we basically work with NN, that is deep neural networks. Okay, the accuracy that we achieve using deep learning is more in comparative with machine learning. And in machine learning, we need some amount of help of users, okay, humans, to train, to test, and to fine tune the system. Whereas in deep learning, the involvement of human is drastically drastically less. Okay, it's drastically less. The accuracy level that we achieve from deep learning is more in comparison with machine learning. That's the first difference. The second, the human involvement is less when we work with machine learning algorithm and deep learning algorithms. Okay. So we started with artificial intelligence, okay, in 1950s to 1980s. And then from 1980s to 2010, we work with machine learning, okay. And then now it's deep learning. It's booming like anything, okay. It's booming like anything. So both machine learning and deep learning can work with numerical and non-numerical data for regressions and also for classification problems. If I want to work with object recognition and language translation, deep learning gives me a better output in comparison with my machine learning. That I'll tell you an example. Okay, I'll tell you an example how it is different. The accuracy level that we reach from deep learning is more in comparison with machine learning, and the involvement of human is less in deep learning, but it is little more extra when I work with machine learning. Deep learning is machine learning. Okay, it's a subset of machine learning. Here we use neural networks that enables the machine to make accurate decision without the help of humans. Okay, almost there is no help from human when I use my deep learning models to train my algorithms. Okay, so what does machine learning do? So I feed algorithms, I give the data to that system, it will parse the data, and it will learn from the data. There are two types of learning. Either it will be supervised or unsupervised. I'll tell you in detail about supervised and unsupervised learning. And from that, what we have learned, it will make us to make informed decisions, right? Say, for example, in today's example, I'll be telling about a sales data set, okay? A sales data set is taken. So it has got different parameters. Okay, so once I give it to my system, I need to figure out in machine learning what is my data and what is my target. What would be my target in sales? My target in sales will be, okay, whether my sales is won or it is lost. Okay, and what are the parameters that aids to accomplish my sales? Okay, so I'll be splitting into data and target. So data contains every parameter that aids me for the sale, and my opportunity results will be my target. So whether my sale is won or lost. Okay, and some other, that is example that we'll be seeing about for the demo session today. And another easy example, I know everybody you use YouTube, right? Once we see a YouTube video, the next YouTube will be recommended. That's a best example of recommendation system. What would be the next video? If I'm going to hear this kind of songs, if I keep listening to the set of songs, YouTube itself makes my own playlist. Okay, these are the patterns of how I work in my system. And this example also, if you search something in Google for some time, that time if you're not logging into your Gmail, all right, and after some time if you log into your Gmail, the product that you searched in the Google, the products of the recommendation will be shown as ads in your Gmail. How many of you have experienced it? I will repeat it. If you search for some products in Google, take it in mind that you are not using your Gmail, okay? That you are not logged into your Gmail. You are searching some product. After some time, you log into Gmail. If I want to search, if I'm searching to buy some tables, okay? I'm searching to buy some tables in Google. Then I close the Google. After some time, I open my Gmail. When I open my Gmail, onto the right, how many of you have seen the ads that refers to the same object? Say, for example, if I'm searching for tables to buy, the same tables. Yes? Yes. Most of you had said X. Yes, you have experienced it. Yes. That is an example of machine learning, which means whatever you search in Google, right? Google, it trains your system and they know that these are the data that you needed and it is reflecting. So it is kind, and if you're a person who likes to listen to rock music, when you open Google, then the list of rock musics you come. Then if you want to hear only mild and melodious song, then it will recommend a melodious song. Yeah, everything is stored. Whatever we do onto our life, it is stored in the Google, right? Lot of automated system. You would have also experienced once. Lot of recommendation system also works with machine learning. If you buy some product in my Amazon, beneath you can see customer who viewed this product has also viewed this product. How many of you have experienced it? Yes? Yes. So, and if you buy in Flipkart also, the product, those who have brought this product have viewed this product. So that are the examples of recommender system. So even in my research company, one of the scholar, they developed that is a recommender system, right? They have developed a recommender system using machine learning. Okay, and one such student who came into a system, because students also come, right? Like UG students, PG students, we basically work with research, but students and PhD scholars also, they come. We give training to them. We take the scholars, we give training, and the scholars develop the products for their PhD, right? It's for their research. Okay, we get the problem definition and we give them solution on what tool they should be trained to that. And in one such student, right, one such person in our company, the particular student took only the text, the review text, okay, I think it's more than lakh, okay. The review text has been taken, and once it is fed into my machine learning algorithm, and my system was able to, the algorithm that we developed was able to tell us what kind of rating can be given for 1 to 5. So that is text processing, like natural language processing. So if it is good or not good, so a lot of words are picked up and it has been synchronized, and the machine is trained in such a way, so when I just feed into my system my review text, it was able to figure out the stars or the rating between 1 to 5. So we have to recognize the patterns, and accordingly it is done. Okay, so there are lots and lots of machine learning models. We should know what model fits what. Okay, for a lock, there is only a key. So we, as a researchers, you should be very definite in finding which algorithm model best suits your application. So I always tell researchers, if you're going to use a modeling method, at least try with 3 data sets to find out whether my algorithm is fault tolerant. You can start with 50,000 data, 5 lakhs data, and 10 lakhs data. And second most important thing is that you should train it with at least 4 to 5 algorithms. And then we have to figure out which algorithm is the best from the performance metrics. So if an AI algorithm returns an incorrect prediction, so after my algorithm, if it gives an incorrect prediction, in machine learning, there is something called hyperparameter tuning. So we can tune the parameters after we train and test and we find the prediction. If it is not up to the expectation, we do the adjustment, which needs human network. But with deep learning models, an algorithm can determine itself. If the prediction is not accurate, then it will go through its own neural network. Okay, that's the difference between machine learning and deep learning. So in machine learning, we need to fine tune the parameter, and in deep learning, the neural network itself tunes the parameter. We are going to see an example of flashlight. Listen carefully, the example of flashlight and how it is different from machine learning and deep learning, right? If I'm using my machine learning algorithm, and also you can use voice recognition system also for your machine learning. Underline this point, whatever is your data type, it is a CSV file, it's an Excel file, it's an audio file, it is a video file, or it is an image, anything can be fed into your machine learning, and the algorithms should be chosen such a way with reference to your data type to discover the patterns that is involved. All right, so machine learning could be programmed to tune, okay, whether, say for example, a room is dark, Okay, when I go and say into the room the word dark, okay, when I say the word dark, the machine will try to understand my voice recognition and it will switch on my light automatically. Able to understand? So even most of you, if you're using Apple phone, you have the app called Siri, right? So whatever we say, it opens, right? Same way in machine learning, if I have programmed my algorithm in such a way, if I go to the room and if I spell the word dark, how many ever times I spell the word dark, the light flashes over. Okay, this is what only when I spell the word dark, the light will happen when I'm using my machine learning algorithm. Okay, but even if I go into this room and say some other words, my machine learning is trained only for the word dark. But in deep learning is more, okay, deep learning is more accurate and efficient than machine learning. So if I go to the room, if I say I can't see, that also will be recognized in my deep learning algorithm, whereas it cannot be recognized into your machine learning algorithm. If I go to the room, if I see I can't see, the light switch won't work, why it is dark, so whatever I speak, so from the neural network, okay, you will be able to figure it out. Okay, you'll be able to figure it out, and the system, because it is self-tuned, okay, it is self-tuned in your deep learning. So they learn through their own methods of computation, a technique that makes it similar, that has its own brain. Okay, but I underline this point: human can never be replaced, but still to the maximum it is trained in such a way. Deep in machine learning, what I've trained only will be given. Okay, but in deep learning, it thinks it's something like we have a set of students in our classrooms. Okay, we ask a set of questions. Okay, if the same question appears in the exam, students will be able to write. But nowadays in exams, we give some creativity, application kind of questions, which needs the students to think and apply to the problem and solve it. Which means the students should have a good thinking and application capacity to solve the problem. So like that in machine learning, like average students, what the question you give, the same question they'll answer. But when it comes to application, only the toppers and who can understand and respond only be able to understand. That's the difference between machine learning and deep learning. Whether you're able to understand machine learning, deep learning, any questions till now? Okay. Okay, you're able to understand. Okay. Now, what deep learning uses? Okay, here we use a layered structure of algorithms called as artificial neural networks. Okay, artificial neural networks. So, like layering will be done. So the system is given in and out of the system. Okay, that is inspired by the biological neural network of human brain. So it leads to the process of learning that's far more that's far more capable than of a standard machine learning models. What cannot be done in machine learning can be done in deep learning. Okay, so deep learning, it itself, it's a kind of self-learning mechanism. Okay, self-learning mechanism. Okay, about machine learning and deep learning. You want one more another live example. So if I take my system, okay, if I take my machine learning algorithm, I'm feeding into my, for example, if I'm going to do my prediction analysis, I'd be showing the example of prediction analysis. If I'm going to give a same data set, okay, but for today's example, I've taken different data set, but if you can also try using the same data set. So these are the houses. Okay, it has got 2-bedroom, 3-bedroom flats, and this is the location, and this is 5 feet. And I feed the same system into my machine learning algorithm, and it will tell me whether it is okay to buy this house or not okay to buy this house. Okay, and the accuracy level will be less. But same thing when I give to deep learning, it will take a layered layer, and the accuracy level, I feed the same data set. When I feed into a system, the accuracy will be more with relevance to my comfort zone. Okay, to my comfort zone. The same thing if I do, if I'm going to take a same example of students. Okay, or if we take an example of students in our school, in our students, we have generally we have 3 set of students. Students who learn, okay, students who learn below average, students who learn average and above average. Okay, so the students who learn and below I need to classify them. Okay, so I will be giving to my system the student name and the set of marks. My machine learning will cluster it into 3 levels. How many number of clusters I'm going to give? But the same data set, when I feed into my deep learning, where I use Keras and TensorFlow, it will create its own different layers. Okay, it could be dense or different layers. And when I get the results of clustering from my deep learning is more accurate in reference to my deep learning. Okay, in reference to my machine learning. So a neural network changes the results frequently, so it cannot be used for fraud detection. No, it can be used. It does the fine tuning. Okay, say for example, if you're going to work with credit card fraudulent system, okay, with these parameters of this kind of transaction, I can tell to the system that if the parameters of transaction are like this, then it is a fraudulent or non-fraudulent. My machine learning also will do the same. Okay, but same data set, when I give it to my deep learning, it will self-learn, and the layers will be fine-tuned more to find between my results of my machine learning and to my deep learning. What's the, say, Niradi ma'am, what is the difference between neural net? In deep learning models, we use artificial neural network to process our data, to find the patterns of data. So deep learning algorithm uses ANN, which is called as artificial neural networks, which is trying to replicate brain. Okay. The same question one more person has asked, what is the difference between neural network and deep learning? Deep learning algorithm uses artificial neural network. Okay, is my point clear? DBMS, it's a traditional database system. From DBMS, I can just process my data. Okay, one ma'am has asked where DBMS can process my data. So how many of them are above, below, but I will not be able to find the patterns of it. But in machine learning, if I given my data, it will be able to find in my patterns what is available, and it will aid me to improve my business. A lot of business analytics are done using this. All right. Okay, coming back to our presentation. So Google created a computer program, okay, with its own neural network, which is called Go. I don't know if anybody has played Go language. Yes, no? Okay, I'll show you the website of it. You can try it out. Okay, by playing Go is like I playing with my system. So AlphaGo is a program. Yes, thank you, sir. Okay, ma'am, I'll try to use with ensembler. Yeah, ensembler is a deep ensembler classification can be done, which gives even more accurate results, right? And Google created a Go game called as AlphaGo. So once they started working with, they gave a neural network layer to work on with that. So once they started playing, the computer was able to defeat even the best Go players, the professional Go players. And this is the website of it. This is the best example of deep learning that's better than machine learning. So, okay, you can make a note. This is the research, okay, that goes. So AlphaGo is the first computer program to defeat professional human Go players, the first to defeat Go world champion, and is arguably the strongest Go player in history. So which means deep learning is, so it knows what would be the next move so that it could win. Okay, if I do give the same game to machine learning, sometimes the machine wins, mostly the human wins. But when I was able to play, when I was able to train this AlphaGo using deep learning algorithm, the deep learning algorithm won the mission because it is self-learning and it predicts what would be the move. All right. Yeah, I always say, some of you have asked whether can we learn machine learning, deep learning online. It needs lot of, you should learn in such a way, because here in my company and CIRF, we give a training for 20 hours, 40 hours training, right? So online training also we offer, okay? So that time we give you entire channelization, the main method, how you should learn, okay, the main method how you should learn. So once last week only I completed one batch of machine learning, right? That's a smaller course, but if you want to learn deep, you have to learn with machine learning and deep learning. All right. And now we move on. So the amount of data that we work with learning algorithm is more when we work with deep learning. So Machine learning, I told it passes the data. The basic difference between it passes the data, we learn from the data, and we give the informed decisions on what it has learned. Okay, deep learning structures. Okay, here we create an artificial neural networks. Most of you have got a doubt. What is neural network? What is deep neural? What is deep learning? So machine learning, we use algorithm to parse the data. There are different algorithms. I show you the demo. Okay, we have to learn from the data, and from the data I can make. So if I'm going to take a sales data, from the data I'll be able to give. So if I just feed into the data, I'm not going to give my target whether it is won or lost. My system will say with these patterns of transaction, my sales will be a win or my sales will be loss. If I take a medical data, all right. So if I'll be showing medical data for deep learning tools. So if my patient is having these parameters, then I can say he's this patient could be diabetic or he is not a diabetic patient, right? So that can be done in machine learning and more accurate in deep learning. Neural network like RAS are not used in machine learning, but it is used only in deep learning. So deep learning is a subfield of machine learning. Okay, but both falls under the category of artificial intelligence. Deep learning is what powerful, the most human-like artificial intelligence. Is it clear now? So artificial intelligence is the base from which we move on to machine learning, where we parse the data and find the patterns of the data, but it needs some human effort, okay, some human effort to understand or fine-tune it. But more self-learning is your deep learning, which enables you, the system itself, to predict and fine-tune the accuracy. Fine-tune the accuracy. Now we'll be seeing what are the major steps that is provided, okay. Yes, I'll come on to the questions. Okay, there are many questions going on. I'll come on to the questions. Okay, at the end we'll have a half-an-hour session on the questions that I will answer to you. Okay, a machine learning projects. Okay, if you want to develop a machine learning project, what are the steps that you need to do? Okay, so first you should define the problem clearly. Okay, we have to define the problem clearly. So what is the problem I'm going to address? Okay, say for example, if I'm going to take my medical data, if I go to my medical records and if I'm going to get in the data, right? So my medical data will have everything: my date of birth, my address, my blood group, and many such things will be there. So if I'm going to say for cardiac, then I have to take only the values of what is needed for cardiac. Then if the values are like this, then I can predict that this patient would like to will have a heart attack or will not have an heart attack. Or if my parameters, if my blood sugar or my BP or the other parameters are like this, then I can predict whether this person may get a diabetic within the next 10 years or will not get a diabetics. Okay, so these are the things. So I have to define clearly the problem. So many of you are research scholars also. Okay, wherein you need to understand clearly the problem that is defined, because many research scholars come to my company, but most of them are not clearly defined. So before you start with the machine learning, you should clearly define what is the problem that you're going to address. Okay, so once that is done, the most important factor is to prepare your data. Okay, then here in my company we teach them how to take benchmark data. So, okay, benchmark data sets will have all varieties of data, okay, which will enable me, when I feed into my system, that will tell me whether what algorithm to work. Okay, and also we help people to get the data sets what is available, because we should know there are pools of data set available. You should correctly take the data set. If you itself prepare your data set, right, then you will prepare your data set in such a way what is needed for you, and you'll get your result, which means your algorithm will not be perfect. If your algorithm is perfect, you should definitely use benchmarked data set. And the third step, you need to evaluate the algorithm. How do I evaluate the algorithm? So if I want to evaluate my algorithm, so I will be taking at least 3 different data sets, feed into 3 to 4 algorithms, and from which the accuracies from the performance metrics I can find for this particular data set, for this kind of application, which algorithm suits the best. Okay, there are like a sea of algorithms available, but we should understand the algorithm and feed our application into the particular algorithm, and then we give. And once we evaluate the algorithm, then we need to improvise the results. So that is called as hyperparameter tuning. Optimization needs to be done. And again, if you train the algorithm, the accuracy will be more. And then we'll be presenting the results. Now we'll start the step by step. First, we have to install, we'll be using Python. Okay, then we need to load the data set. Okay, then you need to load the data sets. Once you need to load the data set, you have to summarize the data, which means a data visualization is more important. What is visualization? Say for example, if I give you a 10 lakhs of record in DBMS and ask you to find the results, whether you'll be able to understand your data? No. Yes or no? You will not be able to understand my data. So more importantly, you should know how to visualize your data. So data visualization plays a vital role in before we start with an algorithm. Okay, before we start with an algorithm, we should understand our data. What are the kinds of data available? What are the insights that would be needed for me to get my results? Okay, what are the parameters that aid me, will give solution to the problem that I give. And then we have to visualize the data. Then we have to evaluate some algorithms. Okay, some of them you take one data set, feed into an algorithm, you get your results and you finish your research. No, that is not correct. Okay, that is not correct. Here we guide them on how to work with algorithms, what algorithm will be best suited. Okay, and we evaluate some algorithms and then we make some predictions out of it. Okay. I'll remove this somebody's. Okay, hide it. So some of them wanted to hide that. I have hidden it. Okay. So okay, I've hidden the comments. Yeah, I've removed the pop-ups also. Thank you. Okay. And now, what are major libraries that you need when you want to work with machine learning? SciPy is one of the packages that you need, which is called as scientific Python. Okay, which is called as scientific Python. And the next is NumPy. Those are new to it, you can make a note of it. NumPy stands for numerical Python. NumPy stands for numerical Python. And Matplotlib. Matplotlib is used for plotting graphs. I told, right? When we take our data sets and we upload it into a system, we need to visualize your data and summarize your data. For visualization and summarization, we need Matplotlib and Pandas. And sklearn is the package which will enable me to train my algorithms and test my algorithms using different machine learning algorithms. So in Python itself, they've given plentiful algorithms for us to view it. Okay, they've given plentiful algorithms for us to train, for test, and what is to be needed. Okay, we should know what algorithm we should take and how it should be posted on to my system to evaluate. For the set of machine learning algorithms, we use this package called sklearn. So these are the packages that's mandatory: SciPy, NumPy, Matplotlib, Pandas, and sklearn. Okay. So I'm going to take this data sets. Can you all see the data set now? Okay. So most of you are giving good comments onto the live chat. You can also like our channel, subscribe to our channel. After the end of the session, the live chat will go. There will be comment session. So in the comment session, I wish the participants to post your feedbacks. Okay, there will be comment section, comment. That place you can post your feedback of the session. This session will be live always. You can anytime come and view the session, right? So thank you all. So I'm going to take this data set, sales data set, which has got an opportunity number, the supply subgroups. It is the parts of car sales. Okay, it's the parts of car sales, the region. All right, from how it is routed to market. So all the car parts are not directly from the factory to the people, right? It goes to tele advertisements, to salesperson, to reseller, and how many days it was there in the sales stage. okay, opportunity results, then how the change count, how total days identified through closing, so how it is qualified, the USD dollars, okay, it's a benchmark data set, okay, it's a benchmark data set, and how it is taken from revenue, okay, and competitor and ratio. So all these parameters, okay, all these parameters other than my opportunity result. My opportunity result is my target. My opportunity result will have whether my sales is one or not. So that is what I need to predict it. So in my training, I'll split my data into training set and testing set. Okay, I'll split my data into two types, training and testing. So my training set again I'll split into data and target, and my testing also I'll make into data and target. In data I'll get all these values, okay, in data I'll have all these values other than my opportunity result. My target will have only my opportunity result. Okay, I repeat, I'll take my data, I'll split into data, train and test. In train again I'll split into data and target, and test also it's split into data and target. My data will contain all my data other than opportunity result. My test, my target will have only test. Okay, my target testing data will contain only my target. Okay, I have to fetch my data set. I have to do the data curation. Okay, data curation. Okay, so what is data curation? We cannot work with machine learning missed values. Okay, we cannot work with missed values. So when there is any missing values, a machine learning cannot work. And also I need to convert all my categorical data into numerical data. My machine learning, whether my machine will understand strings? No. So I have to convert my categorical data into numerical data. First step, I have to fetch my data set. Then I have to do my data curation. I have to convert my categorical data into numerical data. And in pre-processing, I need to extract what are the features that is needed. And also I need to normalize before I feed my data into my system. All right. And I have to do the exploratory data analysis. So this is what is my summarization and visualization of data before I start with my machine learning. Then I give it to my machine learning algorithm, and then I split into training and testing set. All right. So these are the basic steps that is needed to perform our machine learning algorithms. Okay, there are different methods in machine learning algorithms. So if I use classification to identify whether which category it belongs to, if I take a disease, whether this person has got this disease or not, as somebody has said about what is that? He said about fraudulent system. Okay, one of the participant. Okay, you asked for fraudulent system, whether it is a fraudulent transaction or not, so that we can use algorithm like support vector machine, nearest neighbor, random forest. Yeah, so these are the different sky kits, right? You can work for clustering. For classification, you've got ensemblers. One of the professor here has said about ensemblers. There are ensembler classification, K neighbor classification, okay, and naive based classification, linear SPCE, SGD, okay. And then here for clustering, if you want to cluster it, so if I give my newspaper data into it, so if it will cluster into it's a sports data, or it's a politics data, or it is a normal news, okay. So clustering can be done. If I give my student set whether it's a good student, a below average, average, or above average student, okay. If I say give it to my customers, so customer segmentation, these are the customer who frequently buy from my shop or not. For those application, we go for clustering. And if my application has got dimensionality, if it is more dimension, I will not get my data. So I have to reduce my dimensionalities. And then for regression, if it is continuous values like stock prices, we go for regression methods. Continuous values like drug response, continuous valued attributes associated with an object will be doing it, okay. And clustering, I said, and dimensionality reduction, model selection. After I do my machine learning algorithm, if I want to fine tune my parameter, okay, parameter tuning for improved accuracy, then we go for model selection, okay. There are certain questions. Let me check it out before I start with my running of my codes. So what is this? Good awareness. It is useful. Thank you. And is there any questions? Always there is a gap between real data and the paper. So when we work with the real data, we will not have all clusters of information. So it is always better to use benchmark data. So, okay. Yeah, you can use logistic regression, logical regression. So there is a pool of space where you get your data, benchmark data. So those data are called as benchmark data. Okay. Okay, basic subject. You can join in for the course in our companies. At that time, we give you full hands-on. Here in my company, we don't give like theory session. Theory, we have got a number of people to teach. Okay. So thank you all for the good feedbacks you are able to give. Now, let me move on. Okay, I've opened. So the same data set I've taken, I'm directly taking it from a website which contains my, this is Watson Analytics, sales won and loss, which is a benchmark data set, okay? Yes, sir, it's Kaggle and also in different places also. And sales data sets. So I'm importing my pandas package. I told pandas is used for our data visualization using pandas. I'm taking my data and I'm putting into my sales data. Here, my data set will be converted into my data frame. My CSV value, I'm going to take my CSV value and I'll be converted into my data frame. So I'm going to have 78,000 values, okay, 78,000 rows and 19 columns. I showed you all these columns in the slide. So all these are my data. The opportunity result, can you see the opportunity result here? Only this result will be my target. So I want to predict these values. I will be feeding into my system, and when I feed into my system, I'll give only my data. I will not give my target. What is my target? My target is my won or loss. Only that I will give it to my system. Only the data I will give it to my system. I will not give my target. So from which my system will tell me whether this particular transaction is won or loss. So that is the prediction of my system. But also I have my actual result. So I'll compare both actual and my predicted. Then I will tell how much accurate is my system that is given. All right. And this is the head and tail. I'm first doing my, I told, right, we have to do the summative assessment of our data. So I'm going to find what are the data types of it. If I use the describe function, it will count my median. So it will count every values. So already we have seen the total number of rows is 78,000 something, right? 78,025 rows. So the row value starts in pandas from 0. So 78,025 rows. And I said, in addition, if you want to work with machine learning, you should not have missing values. Okay, you should not have missing values. So I'm just counting it, and also I can compute my standard deviation, minimum, maximum. Okay. And the sales data, how it is shaped. Okay, the sales data, how it is shaped. What are the columns available? I'm using Seaborn for visualization and Matplotlib. So with my opportunity results, I'm taking only one column. Okay, I'm taking only one column, which is called route to market. Okay, what are the different methods? The product is routed to market, and from which how many one are. So seeing this, I can find that it is routed to market using field sales. Is some pop-ups on? Okay. So people doesn't want the pop-up. Lot of live chats. So yes, sir. Offline coaches. In my company also we give direct courses, but due to Corona, we have reduced it. Okay, we are giving online courses and offline courses. Both are there. Okay. So now we'll move on to this. Okay. Yeah, I will explain deep learning also. Wait, I will explain deep learning also. Varsha ma'am. Okay. And field sales, reseller, route to market. I've not started with my machine learning check. Okay, just we are doing a analysis. So we should understand how your data are. And now with my opportunity results, won and loss, I'm going to first is my count plot, and now I'm doing my violent plot. We are doing our violent plot, and I'm pre-processing the data. I said, right, first we need to pre-process. See, for example, I've got lot of string variables. Okay, if I have values in string, I cannot start working with my machine learning. So I have to convert all my categorical data into my numerical data. So I use my pre-processing label encoder. After that, I could find all my categorical data are converted into numerical data. Okay, say for example, if I'm going to have apple, what colors apple will be? Can I have somebody in the live chat response? What colors apple we get? Normal apple. What colors apple we get? Yes. Yes, we get red, and then we also have green apples. So only red and green apples. Thank you for your response. Okay. Oh, very good. Most of you are responding. But if I give into my system red and green, my system cannot understand. I have to convert red into one variable like 0 and green into 1, and then it will understand. If I'm having less number of unique values, then it is easy for me to humanly convert it. Say, for example, I'm going to do my weather prediction. So I'll get my data from my satellite. So for one particular column alone, I will have hundreds of value. So I will not be able to humanly do it. For that, we do the label encoding, and it itself will generate a unique value reference to it. Okay. And then we give and here and my data, I'm going to drop this column. Opportunity number is not going to aid me in my sales prediction, so I'm going to drop it, and I'm also going to drop my opportunity results. And then in my target value, I'm going to have only my opportunity results. In my target, I'm going to have only my opportunity results. So I've split my data into data and target, and there is a module which allows me to split. I told night I'll convert my data set into data train and training and testing, and again training and testing will be split into data train and target train and data test and target test. Okay, so generally we split into 70-30% or 60-40% or 80-20%. So 80% training data, 20% testing data. But to me, I always split into 70 and 30%. 70% of training data, 70% of testing data. In my training data, I'll have both my data and target. In my testing, I'll have only my data. My data, once it is fed into my system, it will give me my result. So I will have a predicted result, and already I'll have my original target. I'll compare both and I find what kind of prediction. So I have split into data and target. Okay. Now I'm going to give into my Gaussian Bayes algorithm. And once I do the prediction, it gives me, so it compares it and gives me prediction as 75%. So then I'm same data set, I'm going into linear SVM model, and then the percentage accuracy is very less, which means for this data set, Gaussian Bayes is better than linear SPC. I'm again trying with another algorithm called K-neighbor classifier algorithm. Okay, and again I'm giving me the same data and my accuracy is 81%. So out of these three algorithms for this particular data set, I can say this K-neighbor classifier will be better for understanding. Okay, it is better. Sorry, it's better for this application. Okay, it's better for this application. And also I am going to do my classification report. Okay, so once I've done my analysis, these are the performance metrics that we should do. Okay, from sklearn metrics, I import my classification report. So my target test is what I have it. Predicted one is the one that is predicted from my machine learning algorithm. So I'm going to compare the values that is given by my machine learning algorithm and my original data. I'll compare both and I'll be able to find which is better, giving the best accuracy. So these are the parameters. The basic parameters are precision, recall, F1 score. So if I give my values into it, okay, if I give my values into it, then it will allow me to find how many true positive. My value is also positive. My machine learning algorithm is also positive. My value is also negative. My machine learning value is also negative. So in my predicted value is 1. My target, my data set is also 1. Then it is correct. My prediction is 1. Sorry, my original is 1, but my predicted value is false, which is false positive. Okay. Actually, my sale is lost and my predicted sale is also lost. Okay, it is true. My sale is lost, but my predicted is true, which means false positive. So true positive, true negative, false positive, false negative. These parameters are taken, and then I will be finding my confusion matrix. So true positive, true negative. Okay, false positive, false negative. So that will be taken here. And then I'll be going on to my ROC. ROC is called receiver operating curve. Okay, using that I'll be finding actually the curve should come like this. Okay, because of the accuracy less, it is bent, and the next curve that we work is precision recall curve. Okay, so these are the different parameter metrics that makes me to evaluate an algorithm. Yes, it's a confusion matrix kind. Yes, sir. That's what we have generated here, the confusion matrix. True positive, true negative. Also, from this data set, 14613 and 3155 are truly correct in my predicted and also in my data set. 3453 was not done correctly, and 2187 was not done correctly. Okay. Okay. Are you able to understand? Any more questions? Okay. Am I fast? Okay. So now we'll move on to supervised learning. So supervised learning is that I give into you input raw data. Okay, input raw data, and then because it is supervised, my system also will know apple. So then I go to my algorithm, process it, so it knows the shape, how it is there, and then for modeling I'm giving you another color of apple, and it's also says apple. So like students data sets. Okay, we know how our students are and how we train our students, and we know whether the students will win or whether they'll pass in the exam or fail. So we know about our data set. So that is about we know about the output also. Okay, that is supervised learning. In unsupervised learning, you don't know anything about the data. Okay, you don't know anything about the data. We are going to give apple, banana, and mango. So you don't know what is the output itself. So it will try to learn the pattern. It will try to learn the pattern, and then it will process it, and output it will give me. So there are 3 different data sets available. One is an apple, one is a banana, and another is a mango. So this is if you know the data sets output, then it is what we have worked now in machine learning is that we know whether it has win or loss. Okay. And here in unsupervised learning, we given the data, we don't know what would be our output. So our algorithm will try to find out what are the data available, and it will learn the patterns and it will give us how it will be done. Okay. And now we move on to deep learning. Any questions in machine learning till now? Any questions in machine learning? Okay. Okay, I could not see. Confusion matrix is one. There are many metrics, sir. Actually, for a machine learning algorithm, we've got 35 to 40 metrics are available. Okay, there are 35 to 40 metrics available. One such matrix is confusion matrix. So confusion matrix is one of the basic metric that everybody should use. Okay, everybody should use to find how far our system is better predicted from our original. Okay, how far it is predicted from our original. There are a number of metrics. Okay, so MCC also is one of the good metrics, right? Validation test means, okay, so from a data set, okay, we'll have two. We will be splitting into data and data and target. Okay, first we'll split our data into train and test, and again training I'll split into data and target. Test also I'll split into data and target. So when I give my data to train, I'll give only my data train and my target train. Okay. So when I give into my algorithm, I'll give my data test, but not my target test. So one of the person, yeah, we have MOUs. We'll see. I'll be sharing all my company's details with you. And one of the professor has asked what is supervised and unsupervised. I'll come back to that before we start off with the deep learning. Okay, so supervised learning means you know the output of the results. Okay, so if I'm going to give into my data, diabetics data set, I'll be getting only two outputs, whether the patient is diabetic or not diabetic. If I give my exam results to my system will know. If it is above 40%, the student is passed, below 40% is failed. Whenever and wherever, when I know the output of my data set, okay, whenever and wherever I know the output of my data set, then it is a supervised learning. I know about the data. You know about the data. Now I showed you the example of sales data. Right? In sales data, I know whether my sale is won or lost, only two open. So I give a set of the data, and in my training, it will try to learn my patterns and what would be desired output. Then I feed into my algorithm, it processes and gives me the output. So when I give on my testing, I'm not going to give what output. I'm going to just give a green apple. My system will say it is an apple. See, the difference of my training is different and testing is different. So what questions you ask in your college will be different. What question it is coming in the semester is different. But still, we know whatever question is given, these students will pass and these students will fail. Okay. In unsupervised learning, you don't know anything about the data. Okay, you don't know anything about the data, right? I just give you the data. In my data, I have different patterns available. Okay, different patterns available. I will not know what is my output. So I just feed into my system. My system will try to learn what are the patterns available, how one pattern is different from another pattern, and there is different algorithms for us unsupervised learning. And from there, okay, from there, I will be processing the data and my output. What are the desirable outputs from the available input will be given in my unsupervised learning. Able to understand? In unsupervised learning, I just feed into my data. Okay, I just feed in my data, but I will not know what would be my predicted output. Okay, my system, my algorithm will itself figure out the different patterns available. Okay, will itself find out what are the different patterns available, and then from which I'll be able to take out my output. Right? There's some questions there. Are there algorithms directly available in any platform so that we can just give the data? Oh, you should know how to take in your data, how to feed in your data, and how to predict it and train it. Right? Shall we generate patient data from symptoms of disease? There are especially if you want to do for medical diagnosis, there are n number of benchmark data sets available. Okay. Dimensionality reduction needs more. So if there is more dimensionality of the data, if I feed into my system, it will not be able to predict my results properly. So dimensional reduction is one of the metric. It will extract the necessary feature that is only necessary for the particular problem to be solved. Okay, and then there are different algorithms for pre-processing and also for dimensional reduction. The feature, what are the needed features to be extracted, and from there, when I give into my system, then it will be easy for me to get it out. Okay, so training, I give both my data and target. In testing phase, I give only my data, not my target. So okay. So now we'll move on to deep learning. Now is it understandable? Okay, can we use machine learning on education? Yeah, we have a school, we have given our data sets and we work with education institution you can work with. Okay. So now we will move on to deep learning. Okay. So the machine learning, I just extract the feature and I went to my classification whether the sale is 1 or not, and then I gave my output. So this is about machine learning. What is deep learning? I said deep learning uses what network? Deep learning uses is it okay? Oops, I hide it off. Sorry, I'm forgetting it often. Okay, to remove the comments. Okay, so in feature extraction, we extract the necessary feature and then we give into my classification. I know the output. So that is what is machine learning. In deep learning, the feature extraction and classification are being done in different layers, neural network layers, and from which I take my output, whether this is a cat or it's not a cat. Okay, so this is the basic difference between machine learning and deep learning. So in machine learning, I take feature extraction is a separate. That is what you asked in dimensional detection, and then my classification is a separate step, and then I get my output. But here, as I extract my feature and classify, if there is any doubt, again it goes to the feature extraction. It is again modified and then it is classified. So deep learning, this is where your deep learning gives more accurate results in comparison with your machine learning. So what are the different steps in deep learning? We have to load the data. We have to pre-process the loaded data. That's very important. We have to define which model you're going to work on with. We have to compile the model. Then we have to fit what is the model. I'll show you every step now. And we have to evaluate it and make your required predictions. And we have to save the model. So therefore, different models, there are different optimizer available like Adam. Okay. And different optimizers are available. We should know to train a data set with different optimizers and different dense layer, how many layers we know we need to want, how many approaches we need to want. And some of them you're asking, the level is little high because the topic is given as machine learning and deep learning. So that is what we are going to the best of my ability. I'm trying to dilute it, right? So these are the steps that is needed for machine learning. Okay. And these are the applications. Okay, these are the tools that we use. Keras. Okay, Keras is a simple way to create deep learning models. Okay, and in the back end we use TensorFlow, Theano also. Okay, back end we use TensorFlow or Theano. So Keras is a package which gives us a wide range of deep learning models, where from which it will create different neural network layers. Okay, and it enables faster experimentation. I told you about AlphaGo, right? So which is very fast and better than how a human brain will play for the game. It runs in CPU and GPU also. Okay, here I'm going to take a diabetic data set, PIMA. Okay, PIMA is a diabetic data set. It's a benchmark data set. First, I used WA, Watson Analytics Sales Win or Loss, and I have to load my data. I have to define what Keras model, because Keras is where my artificial neural networks will be built. And third step, I need to compile the Keras model. Fourth, I have to fit in my Keras model, and next I have to evaluate it, and then I have to make prediction. Okay, now we will move on to this. Right. So we have 440 people watching on live. Okay. So I'm just taking my data set. Okay. I'm just taking my data set. Yeah. So here I'm importing pandas and NumPy. Okay, I'm importing pandas and NumPy. And here you have got keras.models. There are different models in Keras. Okay, when you Google it, you'll be able to find Keras models. Okay, if you Google it, you'll get a lot of Keras models available. Okay, I'm not going to do that because okay, there are different Keras models available. Okay, Keras represents our actual neural networks. There are different models available in Keras. Okay, out of which I'm going to take one model called as sequential. Okay, I'm just going to import sequential model, and you know there will be different layers, right? So to be different layers, and I'm going to use import dense layer. Okay, there are different layers available. I'm going to use dense layer. I'm importing this data set. I told, right, PIMA data set. So pregnancy, glucose, the blood pressure, the skin thickness, whether they've taken insulin, the BMI, the diabetic pedigree function, what is the age, and what is the outcome. Outcome, yeah. The outcome is whether the patient is a diabetic or not. Okay, if the patient is a diabetic or not. So I have my data, I have my target. So what would be my target? Outcome will be my target. Okay, outcome. Okay, so I'm, what is that? Okay. So here I'm using my own system to run it. Okay. I've uploaded my diabetic CSV, and my data is these and my outcome is this. Okay. So in my data, I'm dropping out my outcome. So I will not have my data. My target would be my whether the patient is a diabetic patient or not. Okay. My data is a diabetic patient or not. Okay. And so this is my X. So here you will not see my outcome. That is my data. X is my data. I have all my values. Okay, I have 768 rows and these columns. And here you remember I imported the sequential. Okay, the Keras model. I'm going to imported the sequential model. You remember when I told in the slide, you have to define your Keras, what model you want. Sequential is a model, and then I have to compile it. Then I have to fit in your model. So now we'll be fitting it into 3 layers. Okay, the dense layer, what would be input dimensional. So activation also different methods are available. All right, and I'm having these layers, and then this is where I define my Keras model. You can increase the number of layers even for fine tuning it. Okay, and I'm compiling it. Okay, there are different losses here. For this example, I've taken binary cross entropy model and optimized it as Adam. My metrics is how much accuracy. There are different metrics to evaluate. I'm going to find how my metrics will be only my accuracy of each layers. Okay, so I'm going to take the accuracy of each layers, and then model dot fit. Okay, model dot fit. I'm going to give my data and my target. I can define how many approaches. Okay, here I've defined, sorry, here I've defined 150 approaches. So from first approach, my accuracy was 56. Okay, as I increase my number of approaches, okay, as I increase my approaches are getting increased till 150. Okay, and then you can see the accuracy is got increased to 70%. So when I print it out, my accuracy of my system is 78. So my deep learning algorithm will tell, if I give it to my system, whether the patient is this patient is a diabetic patient or a non-diabetic patient. So again, here we imported NumPy and Keras. So these are the different parameters: how many times the patient was pregnant, so their levels, the blood pressure, so different variables, and whether if the patient has got diabetics or not. Okay, if it is 1, they are diabetic patient. If it is 0, they are a non-diabetic patient. So feeding these data into my deep learning of different layers, it will tell me how it works. Okay, so now I can tell you how we have been doing it. My company's website. Okay, my company's website. You can all log in now. I'll tell how even machine learning and deep learning works in business analytics. This is my company's website, cirf.co.in. Okay. So if you all try to log into this, I will show you how demographically we are there. So here we tell about what are the courses. We just completed machine learning course, the digital classroom course, and several projects are going on for companies right now. Okay, and here we train people on big data analytics, data sciences using Python. That's the first level you should learn. And second, you should learn about data visualizations, and then we need to move on machine learning, then on deep learning. Okay, and I wish the participants, we have got several participants, and I'll show you how these machine learning and algorithm live example now. Okay, Can you just open my website, cirf.co.in? So I will show you the demo. You will understand how powerful is machine learning, because I will be able to show you now that if you all come into the company website, I'll take up your questions now. I'll show the demo of this. It's a real time. You can see how machine learning is strong enough. Okay. It is getting loaded. Yeah, we provide training to students also. See, at CIRF, we provide training to students online and offline too. So from Sangeeta ma'am, she has told all the participants are requested to fill in the feedback. So until 5:30. So they will be giving you the link. Okay. This is my company's website, www.cirf.co.in. So I'm not doing anything with you, but in real time, I can show you now how many of you are viewing my website. We have got more participants now. We have almost 490. I request, if you find the session was useful for you, if you liked my session, kindly like the channel, comment the channel, and subscribe the channel, right? 3 things you can do. So it's like 8th or 9th time I'm doing a webinar during this lockdown session itself. So the next time when I do a webinar, you will be intimated currently. Okay. So kindly share, put your comments. How did you like the session? What set of time is required for machine learning? So we have different slots. Okay, 40 hours will be more than enough. Okay, 40 hours. You want me to mention the website link again? www.cirf.co.in. And some of them were asking my mobile number. I'll share my mobile number 90030213555, and my mail ID Doreen CIRF@gmail.com. Okay. So if you find the session, most of you are putting in live session. I wish the participants to click like the video, subscribe the video, and comment. On the comments, kindly, I wish the faculties, the participants are viewing, to give the feedback about the session on the comments. So I can see right now 46 people out of 493 are viewing my website. Okay, I can see from Dumbival there is 1 person. Okay, and you can all see from my screen. And from Secunderabad there are 6. Okay, and from Vellore 1. Okay, from Coimbatore there is 1 person, Salem 1, Bangalore 1 viewers. All right, and from Vellore there is 1 person, and Pondicherry there is 1 person. From Chennai 11 viewers. Okay, so I can get all the 50. I wish all the participants to just open the website, so you will see whether you are. And I can see like 41 people out of this 50. 41 are there just on the home page, and some of them are there in the training. 3 of them are in the training programs page, and some of them are on the contact, implant training, people page, research and training sessions. Okay, so I have been giving training to people. You can see in my training sessions. Okay, in my training program, to different colleges. Okay. Now, due to Corona, we are all on live. So, on Big Data Analytics to M&M Jain, this is like Big Data Analytics hands-on workshop for the students of Jerusalem College of Engineering. This is like for to make the teachers how to use mobiles and laptops to handle online classes at St. Christopher's College. Okay. And this is at Anna University. So we give training, and this is a Python programming for the course to the college students. Okay. To the college students. This is where researchers come and work in our companies, right? And even faculties, they come for training, because I wish if the faculties are trained, that is more important. And it's a Section 8 company. Okay, it's our company is registered under the Ministry of Corporate Affairs, Government of India. Okay, so during faculties will come during the semester holidays. Okay, faculties will come during the semester holidays to get themselves trained and take up the question sessions now eventually. So these are the professors from Lady Wellington College. Okay, so now you can also get all my contacts here. If you click on contact, you'll get my mail ID and my mobile number. Okay, my Gmail ID, and I'll just broadcast my. You can take a contact of this. Okay, if you want to take a screenshot. Now we'll move on to the question session. So now I'll come on to the questions question session. Yeah, you can put your yes. What is the main difference between machine learning and deep learning? Machine learning, we do the feature extraction and then we go to the classification. And there, neural networks doesn't work. But here in deep learning, it entirely works on neural networks. You can ask me, you can call me for MOU, sir. Yeah, I'm in WhatsApp. You can call me in WhatsApp. How to select the topic? And if any of you wish to have a webinar in your college also, you can contact me. So teachers always think that they are more important. Can I have any questions? Yeah, first step you have to, like Sanju Reddy ma'am has asked, data science is what you should learn first before moving on to machine learning and deep learning. I know for some it will be little difficult because the topic was little advanced. Okay, but always if you have a hands-on session, it will be better for a teacher to learn. So when a teacher learns, and through you, thousands and thousands of students will learn throughout your career. Yes, sir. I will. You can call me, and I will tell you the details about the fees and duration of the course of Python. Thank you, Maheshwari ma'am, for the good feedback. Thank you, Harita ma'am, for the feedback. Comment box will come at the end of this session in your YouTube channel. The entire session will be live on channel. Data science is what you take a data, how do you analyze the data? Once you know how to work on with the data, then we move on to your machine learning, sir. So, what is the best tool for deep learning? Use Python packages, Keras and TensorFlow. Very good example on deep learning. Thank you, ma'am. Unsupervised learning, you give all the data into it. Say, for example, I give an iris flower data set. So the sepal and petal width and link, other details I given, my system will tell me what kind of this. Yes, Meenakshi ma'am, we can do an online teaching for your college. That can be done. Yes, there are a lot of application in my company, like mechanical students have completed, and now they are doing they're working in Netherlands and other places, right? And it is used even for graphics people. They come, okay. You have to define of what session you want to provide. You want to start with, okay. If any doubts in research, you feel free to contact me. Now I'll hand over. Yeah, this video will be always there on my YouTube channel. Kindly like, subscribe, and comment to this channel. And the comment, kindly give the feedback if you find the session was useful to you, whether you are able to learn. Okay, so that will give me good insights for me to improvise. Yeah, we can write our own algorithms also. When we come for courses, I teach how to use an existing algorithm and how to write your own algorithm also. Yeah, R is useful, but I feel Python is better, ma'am. Python is better than R program. Can you ask questions? We are going to almost end the session. Thank you. Most of you have given, almost all have given good feedbacks for the session. I hope to recap in the session. We started what is machine learning, what is deep learning. We started with what is artificial intelligence, that is the base. So from artificial intelligence, we moved on to machine learning and then deep learning. Then we found what are the different algorithms available in machine and learning algorithms, what is the steps to do it. And then we took the sales data set and we processed it. And then we moved on into deep learning, and therein we use Keras, and using Keras, how we make a layers, okay. And then we have taken the diabetics data sets and we do the prediction using different approaches. What tools you have, yeah, what approach, what tool you have to use to clean your data? There are different tools, ma'am. There are different tools available. Yeah. Uh, Thank you. And even we have done works on COVID-19 data set. I had a webinar for a college, okay, for COVID-19 entire data set. The talks is there available. We have to define whatever areas you need fine tuning of an algorithm. We can use deep learning, sir. Yeah, we have 522 participants right now. I wholeheartedly thank Kasturibai College for having invited me for this webinar. I thank Sunita ma'am, Principal ma'am, Raji ma'am, Surya ma'am for organizing this and bringing you all together. Like though we are in different destination in India, this college has taken an initiative and brought us all together to share a usable time with you. I hope this session would have been useful to you. And don't forget to like the video, subscribe to it, share the video, and then you can kindly give your feedbacks on the comment. That is my takeaway. All right. Thank you. I'll give the session over to Surya. Over to Surya.
Yes, thank you, ma'am. Thank you so much. It was very informative. Very good evening, everyone. Once again, I'm honored and lucky to have the opportunity to give a vote of thanks on this special day. On behalf of PG Department of Computer Science, I take the privilege in thanking Principal Madam Dr. P. Sunita, Vice Principal Madam Dr. Rashri R, and management for giving us freedom and constant support for smooth conduct of the webinar. I thank Speaker Dr. Robin Madam for enlightening us with the subject machine learning and deep learning. It was very, very useful and quite interesting and informative. I would like to thank Head PG Department of Computer Science, Dr. K. Sunita Madam, for taking the initiative for conducting today's webinar. And I thank Associate Professor K. Lakshmi Rajam Madam and lecturer Ms. Sangeeta for her support. Last but not the least, I thank all the participants for patient listening. For any further correspondence will be done in the group. Thank you. Thank you all once again.
So I put my mobile number on the screen. Those who want to make a note of it, You can make a note of it and you can call me. And I wholeheartedly thank Kasturba College BG, Department of Computer Science, for organizing this event. All right. Thank you all. We will end the session now. So kindly give your feedback in the comment section. So participants' feedback will be given by Surya ma'am. Can you just explain how are you going to give your feedback to the participants? There are many
The
questions
link
on.
is provided in the chat box already, so please fill it up. And the link is open till 4:30 p.m. only. Kindly fill it quickly. If for any other correspondence, you can text us in the group. The link is already provided in the YouTube chat box. Kindly fill it.
Yes. So there are 524 people here. Everybody, the link is there on the feedback link. They've given on the chat box. You can get it from the chat box, because once we end the broadcast, you'll not be able to get the live chats. So don't forget to comment, like, and subscribe to our channel.
Kindly fill
Can we wind
the
up?
form. Kindly fill the form. It's provided in the YouTube chat box.
Can you once again share it, ma'am? Some of them are asking. Can you once again share the feedback link on the chat box?
Yeah,
Live
definitely,
chat?
madam.
And parallelly also, you can give your feedback on the comment box also. Yeah, they are giving the college, they are giving the feedback link in the
The link
chat.
is provided, ma'am. They can fill it.
On the chat box, ma'am.
Yes, ma'am. Yes, yes. YouTube chat box.
Can't find.
I have just posted the feedback form. So kindly, I request all the participants to fill the feedback form. I request all the participants to fill the feedback form. The link is provided in the chat box.
Surya ma'am, can you mail me the feedback link?
Yeah, sure, ma'am.
I'll also try to put it on the chat box.
I have sent you the mail, ma'am.
Yeah, I'm checking it out.
Kindly fill the feedback form, everybody. I request all the participants to fill the feedback form. The link will be
Ma'am,
open.
I've not received the mail.
I have just sent you, ma'am.
Okay, check it out. Yeah, got it, ma'am.
Yeah, yeah.
Yeah. I'll also try to put it on the chat box.
I request all the participants to fill the feedback form quickly.
Yeah. Can you check on the chat session? We have put the feedback form. Uh, I've put the comment on the YouTube link also. Video. Can you all find? It's there. Yeah, this is the link. Yes, you got it. Thank you, sir. So the link
The
will be open.
feedback link is provided in the YouTube chat box. Kindly fill it. All the participants are requested to fill the feedback form. The link is provided in the chat box.
It is already given posted and we are reposting it again and again.
Could you please post it again, ma'am?
Yeah, I posted thrice.
Thank you.
Yeah, some of them they have given that it's done.
Okay.
Yeah, some they have given feedback. They've submitted the feedback. Thank you, Shweta ma'am, for the good feedback.
Once again, I request all the participants to fill the feedback form.
So can we wind up with the session, ma'am? Or we'll wait?
Could you please take up Dr. K. Sunita madam into live?
Yeah, I'll connect, ma'am. Ma'am is on live.
Yeah.
Yeah.
Ma'am, I think it's enough now.
Yeah.
Should we wait for the feedback to be submitted?
We could wait.
Otherwise, we'll give it in the group for filling up the feedback.
Yeah, we have already given it to the people. I've just posted it 5 times. So and people are
That's
getting
enough.
it, and
Yeah.
some of
That's
them
enough.
said they've completed. Some of them are asking about certificates.
Yeah, that we look into it, ma'am.
Yeah,
Now we'll end.
you will be getting it. Okay.
Yeah.
Thank you so much, Sunita ma'am. Thank you, Surya ma'am, and convey my thanks to Raji ma'am.
It's our pleasure, ma'am.
Welcome, ma'am.
Thank you all. Bye bye. Thank you,
Bye.
participants. Bye bye. You all.